Okay, so in the previous segment, we dreamed up this scenario about the frog falling. We found that it plotted an increasing growing rate, a graph, which is in math known as a y=x² graph. So what we're going to do is replot our data to give us a new graph where we're going to plot a graph of distance meters versus time squared. All right, so let's go ahead and revise this table so that we have t squared data versus d. All right, so the first one, 0 squared is still 0. 1 squared is 1, which gives us a distance of 1. 2 squared is 4, and at that data point he had fallen 4 meters. The next data point, 3 seconds, 3 squared is 9, he'd fallen 9 meters. 4 squared is 16, and he'd fallen 16 meters. And then 5 squared is 25, and in that 5 seconds, he'd gone 25 meters. So we have a new set of data to plot, and I think most of you can see. You can go ahead and pause the video and plot it if you'd like, but we get a nice straight line. All right, so now the mathematical model for this straight line is y equals mx plus b, and then let's use proper symbols. Distance fallen equals whatever the slope of this is. All right, so let's go ahead and I'm going to pause the video and have you use some data here. Let's pick out a couple of points we're going to use. Let's pick out that point 0, 0, and maybe that point. Let's call that time squared of 1. All right, so you pause and you try to figure out the slope there. If you've done that, you found the slope is 1. And so we're going to say 1, and this will be time squared plus our y-intercept. And our y-intercept here is again 0, which we don't really need. So distance equals 1 times time squared. All right, so what is the meaning of this? Well, let's see. This is actually related to the number of meters you get for each second that you fall. And because the frog is going faster and faster, as evidenced by the fact he's going further and further, this is sort of the rate at which he's speeding up. Some of you might know that as the acceleration. But if you don't, you'll take physics in 12th grade and learn a lot about that. But for now, we can use our mathematical model to make a prediction, like what would happen if we let the frog fall instead of for 5 seconds, but if we let him fall for 10 seconds. Okay, so how far would he fall if we let him fall for 10 seconds? Slope times 10 squared. And so the distance that he would fall would be 1 times 10 squared, or 100 meters. And that's using that mathematical model. So I want to summarize here just a bit. So in summary, what I've tried to do is show that you can take a graph that you've made, and if it's a linear graph, from that graph you can get an equation which has a general form of y equals mx plus b, where m is the slope and b is the y-intercept, but that we can make that into a more specific equation related to the exact experiment. And then we can use that equation to make predictions. Or to calculate values. We've also seen that if the graph is nonlinear, that we can linearize it and then go ahead and come up with our y equals mx plus b, tailor that for the particular experiment, and again use it to make predictions. Now, the other link on Genesis is to a couple of questions that I'm going to have you work through, where you're going to come up with mathematical models.